morning. So today we are just going to do a little bit of review on the factoring by grouping and factoring completely that I had gone over in yesterday's lesson. So I'm going to use this worksheet 8.8 practice B, and I'm just going to go through probably the odds. And then if you need extra practice, you can do the evens, and the answers will be posted on the Google Classroom. So if we take a look at the first set here, the first set, they had already kind of done the GCF part for you. So it's really just working on that second part where we write the final factors. So if the GCFs are already taken out and the remaining binomials that are left are the same, then all you need to do is put those two GCFs, in this case the 4x minus 3, put that together as one factor, and then your second factor is going to be this x plus 5, and that's it. And as long as there's no exponents, like no x squares or cubes or anything left anywhere, you know that you're 100% finished. Now, if we take a look at number 2, both of these are a minus 3. So we're just going to write down 12 minus 2a. And then a minus 3. Now this one's a little tricky because there's an extra piece here. You might notice that in order to have this factor completely, there cannot be any GCFs that were not taken out. They all have to be factored out. So what can I divide 12 and 2a both by? A 2. So if I take that 2 out, I'm left with 6 minus a, and then I have my a minus 3, and that would be my final answer for that one. Okay, so I'm going to skip over to example 4 now. I guess I'll do evens. So example 4, the two parentheses here are already the same, so that's a good sign. So if that happens, we're just going to take our two GCFs, which are 2b squared and this positive 3, and I'm going to group those together. And then I have my b plus 6, which is going to be my second factor. Now, b plus 6, there's nothing else we can do with that. The first factor has a squared, so you have to take a close look at it and see. B squared, I could factor some more, but 2 and 3 are not perfect squares, so they can't do anything else. And there's also no GCF, so that is as far as we can go, but sometimes there's a little more we can do with that. And then number 5, you might notice that these two are not the same right now because we have an x plus 15 on this side, but the first one is 15 plus x. Now, in this case, because it's an addition sign, I can just rewrite them in the other order and it hasn't changed anything. But if it was a subtraction sign, that would be different. So you have to be careful with that. So now they're the same. So I'm going to take my two GCFs, which in this case are y minus, and this is really a 1 since there was nothing there. And then my second factor is this x plus 15. And I'll leave 3 and 6 for you to do for extra practice. Okay, so now 7 through, I think we're going on to 12. These are all by grouping. So for these, you have to do the GCFs first, and then we'll finish up doing what we just did in the last section. So the first two terms here, you can divide them both by an x squared. So remember, when they both have the same variable, whatever one is smaller. So x squared is the smaller of those two, so that's what gets to come out. Then you're left with a single x plus 1. Then on the second half, they're both divisible by 5. And then you're left with x plus 1. Now remember, whatever sign is here has to go on that number when you take it out. Now I have an x plus 1 and an x plus 1. So I'm going to put my two GCFs together, which are x squared plus 5, and then my repeated factor is x plus 1. Now, x plus 1 is completely finished. It's a binomial that does not have any x squares or cubes or anything like that in it. X squared plus 5, the x squared could be broken down further, except that 5 is not a perfect square, and it has an addition sign, so there's nothing else we can do with that problem. So now we're going to go on to number 8. So taking out my GCF of the first two terms, just like the last one, we can take out a squared, so that y squared can come out. And then we have y minus 14 left. On the second parenthesis, There's nothing we can take out, so it's just going to be a 1, and it's going to have that plus sign because that plus is right there. And we're left with a y minus 14. That's always good. I like this method because when we do this, the two that you left with, if they're the same, it's like a really good sign that you're doing it correctly. So now we have y squared plus 1. I put those two GCFs together as a factor, and then the one that we got twice is the second factor. And it's just going to look like that. Okay, so I'm going to go down to number 10. So when I go to do number 10, again, starting out, grouping the first two together, grouping the second two together, looking for a GCF of each group. The first group here, I'm going to take out the p squared, and then I'm left with p plus 9. On the second half, I can take out a 4, and it's going to be positive, and I'm left with p plus 9. So again, p plus 9, I got that twice, so that's a good sign. I'm putting my two GCFs together, so p squared plus 4, and then p plus 9. Now this one's even closer to having more work because p squared is a perfect square, 4 is also a perfect square, but the plus sign in the middle doesn't allow for us to do anything else. If it was p squared minus 4, then we'd be able to take it that extra step. So let's see what happens with number 11. So number 11, I'm grouping my first two terms, grouping my second two, taking out my GCF of t squared from the first two. That leaves me with t plus 12. Now on the second half, when I take out my GCF, I'm going to take out a 2, but it's going to be a negative 2. And then I'm left with t plus 12 because negative divided by negative is positive. So now I'm going to group my two GCFs together. My repeated factor, which is that t plus 12 that I got twice, is my second factor. And now I just want to double check this t squared minus 2. Can I factor that some more? Well, I have a t squared. I have a minus sign, but 2 is not a perfect square, so I can't do anything else with it. And I'm just going to have to leave it like that. Okay, so let me see. I'm trying to figure out if anything else here is going to work, and I don't think that is. All right. So moving on to the next section, this is factoring completely. So it's critical, guys, to check for that GCF first. Always check for the GCF first. If you forget to, you can technically still finish the problem later, but it's going to make the problem harder for one, and two, a lot of times then people forget to do the GCF at the end, and then they can't find the answer in the multiple choices. So 7 and 28, we definitely have a GCF between those two numbers, right? So 7 and 28 are both divisible by 7. They both have an x, so the smaller of the two will also be part of that GCF. So I'm going to divide both of those by 7x squared. That's going to leave me with x, and then 28 divided by 7 is 4. So it's 7x squared on the outside and x plus 4 on the inside. Now, if I go to number 14, these are both divisible by 4, and they both have an m. Now, I have an m cubed and just a single m, so whichever one is smaller is the one that goes on the GCF. So now I'm going to divide each of those by 4m. So I'm left with m squared minus 4. Now this is where I have to take it an extra step because I still have an m squared, which is a perfect square. I have a minus sign and a 4, which is also a perfect square. So I'm going to have to do that difference of two squares pattern that we did earlier in the week. So since 4 is a perfect square, I'm going to break it up into 2 and 2, and they're going to be the opposite signs because they cancel out, and that's why there's no middle. So that's one of those types that I was kind of trying to get to so you could see when that happens. Now, if we take a look at number 15, we're going to divide out a 2 and a p, and whenever your lead term is negative, you need to take that out on the GCF as well. So we're going to divide out negative 2p from each of these. So negative 16 divided by negative 2 is positive 8p. And there's still a squared on it because You're only subtracting that exponent there. And then negative 2p divided by negative 2p would be positive 1. Now again, even though I have a p squared, 8 is not a perfect square, and there's a plus sign, so I can't do what I did in number 14. Okay, so there's a few more of these, so I'm just going to kind of skip around a little bit just to see where we're at. Okay, so let's go over to number 18. So 18, I want to look for a GCF. So first I'm going to look at the numbers. So 18 and 24, the largest number I believe that I can divide those by is 6. And you'll notice that they each have some form of an X. So the first timer also has a Y, but the second one doesn't, so we can't take that out. But I can take out a single X. So I'm going to put my GCF in the front of my parentheses. 18 divided by 6 is 3. The X's would cancel out, but I still have that Y. Then 24 divided by 6 is 4, and X squared divided by X would leave me with a single X. So that's what that one would look like. All right, so let's see. Moving down to let's try number 20. The number 20, I can take out a GCF of 6. That's the only thing they all can be divided by. The 120 doesn't have an X, so I can't take out an X. So I'm left with X squared plus X minus, and what is 120 divided by 6? 20. Now, anytime you have an X squared, especially with a trinomial, you want to see if you can factor this some more. So what are the two numbers that multiply to get 20 and subtract to get 1? Positive 5 and negative 4. So you'd have to do that extra step there. All right. So let's take a look at number 21. So number 21, we have 3 terms here. They're all divisible by 4, but you'll probably notice that they all also have some form of a z. Again, as long as they all have the variable, you can divide it out, whatever one's the smallest. So the single z is what's going to come out there. So all 3 terms get divided by 4z. So 4z cubed divided by 4z is going to leave me with z squared. Negative 4z squared divided by 4z is going to leave me with negative z. And negative 8z divided by 4z is going to leave me with negative 2. Now again, when you have a quadratic trinomial like we do here, it's very likely that we can factor that into 2 binomials. So what 2 numbers multiply to 2 and subtract to negative 1? Negative 2 and positive 1. So that's how we would finish factoring that one completely. Now notice when you do the GCF, you don't have to do AC method, which makes it a little bit easier. Okay, so I'm going to skip down to, let's see, I'll do 23. All right, 23 is just another one of the grouping ones like we did on the other page. Taking out an x squared, I'm going to be left with x plus 1. And on this side, I'm taking out the 5, and I'll be left with x plus 1, x squared plus 5, and x plus 1. And the 5 is not a perfect square, so I can't break that down any further. All right, so now when we're solving these equations, remember we want to first get it to be equal to 0. So if it's not equal to 0, like for example 26, we would have to move that 250 over like that. Then you want to do the GCF if there is one. Okay, so 10 and 250, there is a GCF of 10. So if I take out my 10, I'm left with x squared minus 25. Now this particular one is a difference of 2 squares problem because 25 is a perfect square and there's a subtraction sign, so we can do the x plus 5, the x minus 5. So then that would mean our solutions are x equals negative 5 and x equals positive 5. So let's say we were going to do number 28. Now if I want to go down to number 28, I'm going to divide all of these by 6. That's going to give me 2x squared plus 3x plus 1. Now this one's very challenging because after you divide out by 6, you still have a number in front of this x squared, which means you're going to do AC method. So this is like a more complicated problem. So 2 times 1 is 2. What are the two numbers that multiply to 2 that add to get 3? Well, 2 and 1. So we're going to recopy this into 2x squared plus 2x plus x plus 1. And now you're going to do your grouping. So this is kind of a more challenging problem here. So I'm going to take out my 2x, and I'm left with x plus 1. Take out just nothing there, so just a 1. I'm left with x plus 1. So my factors are 2x plus 1 and x plus 1. And I had that 6 from the way beginning. And then if I were to get my solutions for that problem, I'd solve each of these, and you'd get -1/2 and -1. All right, I'm going to do one more of these. So this last one here, I want to take out definitely a negative, and then I'm looking to see what is my common factor here between 18, 60, and 50. So thinking about this for a minute, we know we can take out 2 from everything. So let's see if that works. If I take out a -2, I'm left with 9x squared plus 30x plus 25. Now, on first glance, you're probably like, oh, now I have to do AC method again because I have this 9 here, but you might hopefully recognize that 9 and 25 are perfect squares, so we can use that pattern that we went over on Tuesday and Wednesday. So if you know that this is really a 3 squared, right? And 25 is really 5 squared. Then we can do that shortcut where we would just do 3x plus 5 squared. And then we stick that -2 on the front. And that's way easier than trying to do AC method. Then I just have to find that one solution. So subtracting 5. And then I end up with x equals -5/3. So there's only one solution there because you would get the same thing twice. And I guess, let's go down to the word problems real quick. So a countertop. A countertop will have a hole drilled in it to hold a cylindrical container that will function as a utensil holder. The area of the entire countertop is given by 5x squared plus 12x plus 7. The area of the hole is given by this. Write an expression for the area in factored form. So the first thing we would have to do is take the whole countertop and subtract the hole. So we're doing the rectangular area minus that little circle, right? So 5x squared plus 12x plus 7 minus, just make sure that when you're subtracting a trinomial, that negative is going to get distributed. So it's going to be minus x squared minus 2x minus 1. Now we have to combine our like terms. So 5x squared minus x squared gives me 4x squared. 12x minus 2x is 10x, and 7 minus 1 is 6. Now, because they want us to put this in factored form, first thing I would do is divide it by 2, which is 2x squared plus 5x plus 3. And then you would have to do AC method there. So 2 times 3 is 6. The two numbers that multiply to get 6 and add up to get 5 are 2 and 3. So 2x squared plus 2x plus 3x plus 3. And then I'm going to do my grouping. So I have 2x, x plus 1, plus 3, x plus 1, 2x plus 3, x plus 1, and then that 2 would be on the outside. But that's a pretty complicated problem. I'm not going to give you anything that crazy, but you can just see how a lot of the stuff that we've done in this chapter can all be tied into like one simple problem like that. All right, and that's all I'm going to go over in this video. I will post the answer key. We'll have the answer to all the problems. So if you kind of want to do the other ones I didn't do maybe on your own and then check the answers. And then also if you check in at 10:30, it can help you there as well. And you will have a short quiz for homework. It won't be anything this complicated, but we will be doing a test next week. So it'll be a little preview for what you need to know for that. All right, and hope you guys enjoy your weekend. Goodbye.